I said we're going to have a look at analytical geometry tonight, so we'll deviate a bit from Monday night with a focus on the analytical geometry in grade 12. All right, so the circle, for example. Right, the general standard form of a circle, x minus a squared plus y minus b squared equals r squared. All right, so you need to have this bracket squared plus bracket squared equals r squared, and the bracket needs to have an x something and a y, the other bracket a y something, right? This a and b form the center, a, b. And so you'll notice that this a is the opposite sign to that. That's minus a, this is plus a. That's minus b, this is plus b. And then r is your radius, the radius of the circle. Right, so for example, x minus 4 squared plus y plus 3 squared equals 16. Right, because it's in the standard form of a circle, you immediately know that you can write down your center, the x and the y. And remember, if that's minus a, that's plus a. If it's minus 4, it's plus 4. Plus 3, minus 3. Okay. So that's your center. And the radius will be the square root of 16, which is 4. Okay, remember that 16 is r squared. Okay, r squared is 16. So you need to square root both sides to get r. And that's how you get your 4. Okay. Right, so this is how you work with the general form, the standard form of a circle. You are able to read off the center and the radius. Right, now the problem is that they don't always give it to you looking like that. Okay, they might give it to you in a different form, and then you need to rewrite it in the correct form. Okay, right, something like that. Right. X squared plus 4x plus y squared minus 6y equals 4. Right, they could give it to you like this, and they often do in an exam. They give this to you, they tell you it is equal, you know. Guys, can I please ask you to switch off your mics with all that noise in the background? Guys,
I will meet you. I'll also you'll meet me twice and then I'll meet you.
We are recording this and nobody can concentrate with that.
No, go there. Go there. You're right. I'll make you right. Don't know me. What are you under with? Yeah, mine is great. Gucci. Mr. Music.
Right, guys, can you just please listen to me? This is being recorded so that other people can actually benefit from it. So we can't have mics on with people having a party in the background. Please. Okay, it needs to be quiet so that when the recording's happening, which it is, yeah. All right. Okay, so this is your standard form of your, well, not your standard form. This is a circle, they tell you, and you need to put it into standard form, right? So you need to make sure that your x squareds are together and your y squareds are together, or your x's and your y's. For this one, x squared plus 4x, you're going to add half of that squared. So half of 4, 2 squared is 4, and you need to add it to both sides. Okay? You're going to do the same here. Right? Keep your y squared minus 6 for y, and you're going to add half of 6 is 3, squared is 9. If you add it to one side, you add it to the other side. Right, so these three terms form a bracket square. It's quadratic, but it happens to be a perfect square. This first term is the square root of x squared. So x and the square root of 4 is 2. And that sign goes there. Okay, so that means that if you multiply this out, you will end up with those three terms. Okay. Right, and then the next three terms will also form a bracket squared. The square root of y squared is y, and the square root of 9 is 3. So of the first and the last, you take the square root, and then that sign goes there. 4 plus 4 is 8, plus 9 is 17. So the center is minus 2. Remember, it's the opposite sign. So minus 2 and plus 3. Right, that's your center. And your radius will be the square root of 17. Okay. So you are completing the square basically. Okay. You're adding something, but then adding it to the other side. Adding something, adding it to the other side. What do you add? Half of the coefficient of x, and then you square it. Okay. Half of the coefficient of x, half of 4 is 2, and when you square 2, you get 4. Half of 6 is 3, 3 squared is 9. Okay, so you add it to both sides. And then you end up with the standard form where you can read off the center of your circle. Okay. And then your radius is always the square root of that. Right. Right, I'd like you to just give one a try. I'll just give you a minute. X squared minus 6x plus y squared plus 8y plus 3 equals 0. I'd like you to give that one a try. Just give you like a minute head start. And again, they will tell you that this is a circle. They will then ask you to find the center and the radius. Okay? Okay, so you keep your x's together. Leave a gap because you're going to add something and then add it to the other side. What do you add? You take a half of the coefficient of x. So half of 6 is 3, and 3 squared is 9. And if you add 9 to one side, you add it to the other. This 3 needs to jump over, by the way. Then, these two terms, I need to add something. What do I add? Half of 8, 4, squared is 16. If I add it to one side, I add it to the other. All right, so it's half of 8 is 4. 4 squared is 16. Now those two terms will be bracket squared. Square root, that sign. Right? And then these three terms will form a bracket squared, square root of y squared, square root of 16. That sign. 9 plus 16, 25, minus 3, 22. Right, so your center is plus 3, the opposite sign, and minus 4, the opposite sign, and the radius is root 22. Okay. You are very likely to get a question like this somewhere in your analytical geometry. Okay. Right, now what we're going to look at next is a circle with a tangent to it at a point. Okay, it just touches at a point. That's what a tangent does. It just touches a curve, and the circle has a center. If I have my center and I have this point, right, I am able to find the gradient of this piece. In other words, like AB. The gradient of AB is 3 minus 2 over 2 minus 1. So 1 over 3. Okay, that's the gradient of AB. My geometry tells me that the angle between the diameter and the tangent is a 90 degree. In other words, these two are perpendicular to each other. So therefore, the gradient of the perpendicular, in other words, the tangent, is the opposite to that. Opposite plus is minus, and 3 over 1, 3. Okay, so that's the gradient of the tangent. That, of course, enables me to find the equation of the tangent. Right? The equation of the tangent. Tangent is a line. So I'm trying to find y equals mx plus c, where I need to find a value for m and a value for c. And I have the gradient of the tangent. Okay, it's minus 3. So I'm allowed to put it into the m. I still need to find c, but if I want to find c, I need to have an x and a y. In other words, a point on the curve. In other words, the curve being a straight line. And there is my x and my y. Y is 2 and x is minus 1. Right? So 2 equals 3 plus c, and if I rearrange that, I get c equals negative 1. So the equation of the tangent, which is that, is y equals minus 3x, and c is minus 1. Right, so that's the equation of the tangent to that circle at that particular point. Right, are there any questions so far? Nothing anyone would like to ask? No. Okay. We have a tangent at a point. And this is, say, AB. Right, so we know that that is 90. The angle between the radius and the tangent is 90 degrees. So we know that these two have the opposite gradients, right? And if I know that my center is minus 4, 1, and they give me the equation of this line, 2y plus 5x minus 1 equals 0. Okay. And they say to you that you need to find the equation of AB. Okay, the equation of AB. AB is a line. So this is what I'm trying to find. A value for M and a value for C. Right? M stands for gradient. And because of the 90, AB's gradient is the opposite to this one. Right, now how am I going to find this gradient? Well, they gave me the equation of that line, so I can rearrange it. Remember, I want to try and put it in the form y equals mx plus c. So I've taken the 5x over and minus 1, and then I divide by 2. So y equals minus 5x over 2 plus a half. So that means that the gradient of the line, the tangent, is minus 5 over 2. That. Whatever is joined to the x is m. So that means I now have the gradient of the tangents. I still need to find c, so I need an x and a y. And there's my x and y on this line. So y is 1, x is minus 4, and I can easily solve for c because it's the only unknown, right? Okay, so let's tidy this up. 1 equals plus 10. So c equals 1 minus 10 minus 9. And then I can rewrite y equals minus 5 over 2x, and c is minus 9. All right. Now these are the types of questions that they like to ask. Okay. Important. Knowing that the line between the radius or diameter and the tangent is always at 90 degrees, meaning opposite gradient. Okay. Right, any questions so far? This is pretty much what they ask in this section. Right, now in this case, they asked you to find the equation of AB, which you now have, and you do have the equation of the tangent. So you can quite easily find the intersection, in other words, the coordinates of B. Okay, you can find the coordinates of B because it's where the tangent and that line cut each other, right, at 90 degrees. All right. Okay, so all important concepts, right? You can quite easily go and find the coordinates of B by solving these two lines simultaneously, all right? So do simultaneous equations. This is the given one, and the one we found was this one. And if we want to solve simultaneously, we could take this and put it in the place of y and keep the rest, because now I only have an equation with x. Right. If I multiply in, those 2's will cancel, so I'll get minus 5x minus 18 plus 5x minus 1 equals 0. I'm just worried that these are cancelling. They can't have cancelled. This is the equation of that. And then we have this one. I didn't really want this to happen. I know I made it up, but I was hoping that it would work out. Because now I'm going to get 0 equals 19, which is not true, which means there's no intersection. So I've probably just chosen a really bad one, because this obviously does not touch. Okay, so just remember, in order to find that point, it is intersection, right? And intersection means simultaneous equations. All right. Because I made it up, obviously this circle doesn't have a tangent with this equation that touches it. Okay. So hypothetically, simultaneous equations. Right? Not in this case. Does not work. All right? Yours will. If they ask you the question, you'll be able to solve simultaneously, and you'll be able to find that intersection. Okay. It means that there is no intersection of this line with that circle. All right, because it doesn't satisfy it. It doesn't balance. Right? They ask that sometimes. In general, does a point lie on a graph? It only lies on the graph if the two sides balance each other. If they don't balance each other, it doesn't satisfy the equation, well, x and y. Okay. Right. Any questions so far? Nope. Okay, now another thing that I'd just like to point out is the following. If I have two circles and they touch each other, right? They touch each other only at that one point. They touch. It means the following. It means that if you drew a line from the center to the center, so AB, where A and B are centers of the circles, then for them to touch, radius 1 plus radius 2 must equal AB. Okay, that distance, the radius, and that distance, the radius, when you add them, they must give you the distance from A to B. Right. And if they do not intersect, something like that, then you can say that if you added R1 and R2, it would be less than AB. Okay, so these do not intersect, don't intersect. Upside down U means intersect. Right, and your AB is still the centers. Okay, so when you add R1 and R2, and the answer is less than AB, it means they do not intersect. For them to intersect, it's more difficult to see, but just remember, intersect means that R1 plus R2 is greater than AB. Okay, you just change that sign. This one's easy to see. It makes sense. This one's not because of the overlap. Okay.
I wanted to put it down.
Yes.
10 seconds and screenshot this.
Did someone want to ask a question?
No questions, man.
Nope. Right, so what they can do is they can give you the equations of two circles and ask you if they touch or don't intersect or whatever. Okay, and then this is what you need to know. You need to be able to find this. You need to check if the one radius plus the other is less than the distance between the centers. Okay, if it is, then they don't intersect. Right. So they will give you the equation of the one circle and the other circle. You will then read off the two centers, you will work out the length from center to center. And if it is more than, if I read backwards, if it's more than the sum of the two radii, they do not intersect. If you added the two radii and that was bigger than AB, then they do intersect. Okay, important concepts. And you basically need to learn this. All right, touch doesn't incorporate intersect. Intersect means that there are possibly two places. Okay. All right, any questions on anything so far? Does everything seem quite easy?
Hello, ma'am.
Yes.
Ma'am, when you find the gradient for the tangent, is it safe to work it out with the gradient method where you say the radius's gradient times the tangent's gradient is equal to -1?
No, so R1 is a distance. A radius is a distance, not a gradient. This is a
No, ma'am,
distance.
with the tangent on the previous slide, ma'am.
Previous slide?
Yes, ma'am, we have to find the equation of the tangent.
I actually wanted you to find the equation of that. I gave you the equation of the tangent. There it was.
Yes, ma'am, but if you do it, if they ask you to find the equation of the tangent, can you say that gradient AB times the gradient of the tangent will equal -1?
Yeah. But that means you still
Okay.
have to end up with the opposite gradient.
Yes, ma'am.
Okay.
Okay, ma'am. Thank you.
Perfect. Right. Worthwhile remembering this. They do ask it every now and then. Okay. So you need to know how to do it. All right. Right. So do x squared minus 4x plus y squared plus 8y equals 2. Do that and this. I don't want to use that number. Okay, do these two graphs intersect or overlap, or do they not intersect at all? Or do they just touch each other? Okay, so the question will be, do they overlap? Do they touch each other and not intersect? Okay, so you need to check that, and immediately what comes to mind is these equations. Okay. Right, so basically what I need is I need my two radii. Okay, so this one will be x squared minus 4x plus y squared plus 8y equals 2. I'm going to add half of that squared, which is 4, and half of that squared, which is 16. These will give you x minus 2 squared plus y plus 4 squared equals 2. All right, so remember that's why you complete the square, to make a perfect square. Square the first, square the last, twice the product in the middle. Okay, and what do we have from here? We have the center, 2 minus 4, and a radius of root Oh, by the way, I haven't added on my 4 that I added to that side and my 16. Remember, if I do it to one side, I must do it to the other. So this is 22 again. All right, so center, opposite sides, radius is the square root of that. Okay. And then you do the same for the other one. It'll be x minus 4 squared plus y minus 2 squared. There was a 3, and you're going to add the 16 that you added on that side and the 4 that you added on this side. Okay. So let's just double check. I'm adding half of that squared, right? That's why I'm adding, sorry, now I've lost my train of thought. This one we've done already. We've added to both sides. That was the first one. This one, half of 8 is 4, and you're adding 16. There it is. And then with this one, you're adding 4, because half of 4 is 2. 2 squared is 4. And if you add 4 to one side, you must add it to the other. Okay, you guys must just double check me, okay? If I squared that out now, I would get that plus 16. That's why I needed to add 16. And if I square that out, I'm going to get y squared minus 4y plus 4, which I must add to the other side. Okay, so that ends up being 23. So radius, root 23, and center, plus 4, plus 2. Opposite signs, okay? Right, so what you need to do with this now is, now that you have these two centers, you're going to find the distance between them, right? And we'll do a few more of these next time, okay? So you're going to find the distance between those 2 points. So in other words, if you call this A and this B, then AB will be 4 minus 2 is 2, squared is 4, plus 2 minus 4 is 6, squared is 36, which is root 40. Then what you're going to do is you're going to work out this radius, which is root 22, and this radius, which is root 23. And you're going to see if you are using any of the criteria of that previous slide that I said. When you add the radii, does it equal AB? Right, if I add root 22 and root 23, do they add up to root 40? Definitely not. Okay, you can work it out in your calculator. Is it less than that, or is it greater than that? Okay, so if you work out root 22, it is 4 point something and 4 point something, so 8 point something maybe. But the square root of 40 is only 6. So in other words, R1 plus R2 is greater than AB. And remember, if it's greater than, they intersect in 2 places. Okay, important. All right. I'll find some questions from past papers to do at some stage so that you can see exactly how they are working, okay, in an exam type situation. I think that's important. All right, so I basically completed the square for both. Right, it's probably going to cut us out any second, so thank you very much. We'll make sure that the recording is done. Thank you, thank you.
Thank you, ma'am.
It's a huge pleasure. We'll carry on next time.
Ma'am, I have a question, please. A quick question, please.
Message me, okay?
Okay. So I wanted to ask if there's like a probability or a possibility that the next lesson you could do proportionality, if possible.
Proportionality as in similar triangles proportion.
Yes, ma'am.
Okay, perfect. Perfect.
Thank you, ma'am.
Pleasure. Thanks, guys. Great. Work hard. Bye.